Hello, in this lesson, we're going to talk about geometric sequence. Previously, we talked about arithmetic sequence, and we know that arithmetic sequence is defined as the difference between the consecutive terms in a sequence is a constant. It's a difference, But in geometric sequence, it's the ratio. So instead of the difference, it is the ratio between the consecutive terms in the sequence is a constant. What it means, right? What it means is that suppose we have a sequence. So, and this sequence, of course, has many terms, Okay, so what it does, what the feature it has is that it has, the following feature, the ratio between consecutive terms in the sequence is a constant, meaning that if I take a sub 2 over a sub 1, okay, so let me make the fonts just a bit larger, okay, it's going to be a constant ratio. So I'm calling that R, okay? And a sub 2 over, a sub 3 under a sub 2, that's a consecutive term. So a sub 3 over a sub 2, and that is going to be the same constant. And a sub 4 over a sub 3 is going to be the same constant as well. So this pattern will keep going, forever and ever. So what that means is that if we take the first term, to get to the second term, right? So from this expression, let's see what we get. If we multiply both sides by a1, and we will get a sub 2 equals to a sub 1 multiply r. And from that piece, right? From this piece, we get that. From a sub 3 over a sub 2, and we will get a sub 3 equals to a sub 2 multiplied by r, right? We just, in this expression, we multiply both sides by a sub 2. So that's a sub 3 is equals to a sub 2 times r. So what this means is, okay, so let me just make some more space for it. What it means is that to get A1 to A2, right? To get from A1 to A2, we just have to multiply by R. So multiply by R. From A2 to A3, we just have to take A2 multiply by R. Okay, so that's A3 equals A2 multiplied by R. Okay, and continue from a sub 4 over a sub 3, and we will get a sub 4 is equals to a sub 3 multiply R. So from A3 to get A4, we just take A3 to multiply by R. So this process will keep going and going forever. In other words, if I want to get a sub 3, I can get it by a sub 2 times R, or because a sub 2 is equals to a sub 1 times R, right? And times another R, right? Because this is a sub 2. a sub 2 times r, so a sub 2 times r, so that's going to be a sub 1 times r squared. Okay, so to get a sub 3, I can take a1, right? And they take a1 and multiply r again, that I take the first term, multiply r squared, I will get a3. So to get a sub 4, we can replace a sub 3, which is a sub 1 r squared, and then multiply the r that was here. And this way we'll get a sub 1 multiply r raised to the power 3. Okay, so a sub 4 is equals to a sub 1, a1 times r times r times r 3 times, we'll get a sub 4. So this pattern will keep going forever and ever. So let's see what else pattern we can see. Okay, so now, right, let's take a second look at this. Let's take a second look at this. So from A1, okay, so from A1, of course, A1 is A1, right? A sub 1 is A sub 1. Okay, and a sub 2 is a1 times r, right? A sub 3 is a sub 1 times r squared, right? We have just derived that. And a sub 4 is a sub 1 times r raised to the power of 3. Okay? And this pattern keeps going. So what do we see here? So what do we see here is that if we treat first term a sub 1 as the index, 1 is the index for the first term, 2 is the index for the second term, 3, 4, right? A sub 2 is a1 times r to the power of 2 minus 1, right? And 2 is the index here. And a sub 3 is a1 times r to the power 2. 2 is 3 minus 1. A to the power 4, a sub 4 is a1 times r to the power 3, which is going to be 4 minus 1. So we start to see a pattern. If this is the index and this is the index minus 1. If this is the index, right, the power is r to the power of index minus 1. So how about this one? Does this fall in the pattern? Well, that can be seen as r raised to the power of 1 minus 1, right? So keep going, that if I want to have a sub 5, a sub 5, right? A sub 5 would be a sub 1 multiply r raised to the power of, okay, I wish you to guess it. Just hold on, guess it. That's right. It's going to be 4, right? And 4 is 5 minus 1. 5 minus 1. Okay, so now we really see the pattern. So this is going to be, this is a 4 minus 1, right? Hold on, we already have it. Now, what if we get to the nth term? If the index is n, so if I have a sub n term, what would that be? Guess it. Well, that's going to be a sub 1 still, a sub 1, and r raised to the power of n minus 1, right? You see, if the index is 5, a sub 1 multiply r raised to the power 5 minus 1, so always the index minus 1. And this is the general term. This is the general term. Okay, so this is the general term of a geometric sequence. Okay, and of course here we need to understand the meaning, right? We need to understand the meaning. A sub 1 is the first term. Okay, is the first term. Okay, so let's look at some examples. Okay, let's look at some examples of geometric sequence. Now, the first one. Okay, if A is 3, R is 2. Example number 1. Okay, so the first term is 3, and the common ratio is 2. Let's see how the terms will look like, right? So the first term would be A sub 1, right? A sub 1 is 3. So the first term is 3, right? First term is 3. And what will be the next term? The next term is A sub 1. The second term is A sub 1 multiply R to the power of 2 minus 1. Okay, so R to the power of, okay, R to the power of 2 minus 1, because the index is 2, right? So, and because this is 3 and this is 2, so 2 to the power of 1. And the next term is that we can take the second term and multiply another R, right? So it's going to be R squared. So the third term, that's the third term. The fourth term, okay, we just keep taking this quantity, right? So which is the first, second, third, fourth, right? And the first term is 3, and R is 2, N is 1, 2, 3, 4. So 4 minus 1. 4 minus 1, that's going to be a 3. So the sequence then is to keep going like this. Okay, so that's how we see all these terms. This is the first, A1, A2, A3, A4, and so on and so forth. A sub n. Okay, so the nth term is going to be A sub 1, right? Which is 3, multiply, R is 2 to the power of n minus 1. And of course, the sequence will keep going. The sequence will keep going. Okay, so let's look at another sequence. Example number 2. Okay, and this time we want to identify the ratio, the first term, and ratio of a, and of course, this is a common ratio of a geometric sequence. Okay, and let's see what this sequence looks like. Well, the sequence is, so we have 2, negative 10, 50, negative 250, and 1250, and keep going. So how do we identify the first term? The first term is pretty easy. That's 2, right? The first term is pretty easy. So the first term, A sub 1 equals to 2. And let's look at the ratio of consecutive terms. So we take the first 2 numbers. So that's going to be A sub 2 divided by A sub 1. And that's going to be -10 divided by 2. That's equals to -5. The second ratio, a sub 3 over a sub 2. So a sub 3 over a sub 2. And that's going to give us 50 over -10. So 50 over -10. Oops. -10. And that's going to be -5 again, right? Since we're told this is a geometric sequence, you just check a couple numbers. You look at the ratio of these two, which is a sub 4. Okay, which is a sub 4 over a sub 3. And this time we get -250 over 50. And that's going to be -5 again, -5 again. So now we know that the ratio, the common ratio is -5. If we know all of these, what is the general term? General term would be a sub n would equals to a sub 1 multiply r raised to the power of n minus 1. When we plug in the numbers, right? When we plug in the numbers, a sub 1 is 2, right? R is -5. So r will be replaced by -5 and to the power n minus 1, okay? We cannot multiply 2 with -5 because the exponents has to be done first, okay? The same thing is to be said about these terms, okay? You can multiply 3 with 2 here, okay? But you cannot multiply 3 with 2 here because here is power 1. So, right, 2 to the power 1 is 2. So 3 times 2 is 6. But for this part, you have to do the square first. As you get 4 times 3, that's 12. 2 to the power 3 first, then 3 times 8, that's 24. So you have to, we have to observe the order of operation. Okay, that's just by the way, I just thought of that, we might make that mistake. Okay, so that's the geometric sequence. So let's look at another one. Okay, example number 3. Okay, example number 3. We are given a geometric, we're given some terms of geometric sequence. Okay, so here are the terms. The first term is 1. Okay, the second term is 3rd. And the third term is 1 over 9. Okay, and the following term, hold on, remove that comma, okay. And the next term is 1 over 27 and 1 over 81. And then keep going. Okay, so obviously the first term is what? The first term is equals to 1, right? So what is the ratio? You just have to look at the ratio between the consecutive terms, right? Between these two, the ratio is going to be 1/3 divided by 1. So that is going to be 1/3. Okay, so that's a sub 2 over a sub 1. Okay, a sub 1 equals 2, right? And then we look at a sub 3. So you can see we're using definitions, right? So a sub 2, and that will be 1/9. That's a sub 3 divided by 1/3. Okay, so 1/9 divided by 1/3. How do we simplify that, complex fraction? What we can do is that we can multiply a 9 on the top, which is a common denominator between these two fractions, right? And multiply a 9 at the bottom. In the end, on the top, 1/9 times 9, that's going to be a 1. And 1/3 times 9, that's going to be a 3. So we get the same ratio. So we keep going. Okay, what I'm doing here is really to practice complex fraction, right? So let's do one more. So a sub 4 over a sub 3, the ratio of of consecutive terms, right? So that's going to be 1 over a sub 4 is 1 over 27. A sub 3 is 1 over 9. Okay, and we're going to do the same trick, but this time we're going to multiply 27 with 27, and we can do it this way. Okay, we can multiply 27 on top and 27 on the bottom. So we will get 1/3 again. Of course, we're using principal number 1. Anything times 1 stay the same. So as we keep going, we have realized that R is 1/3. Okay, so now what is a general term? The general term would be a sub n equals to a sub 1 multiply R raised to the power of n minus 1. Okay, so then we're going to put in a sub 1, that's equals to 1, and 1 times anything is 1, right? And R is 1/3. So R will be replaced by 1/3. So this sequence is basically 1/3 to the power n minus 1. Okay, so when n equals to 1, which is 1/3 to the power 1 minus 1, and that's going to be equals to 1, right? So this is the general term. Okay, and the next is that how can we construct a ratio, construct a general term so we can tell any terms, right? For example, if I know the general term and I can tell, right, see in 3 of these examples, if someone asks me, give me because I already know the general term, I already know the general form, right? The general term, we didn't write it down here. The general term is a sub n equals to a sub 1, which is 3 times R, which is 2 here, to the power n minus 1. So if I'm asking for the 99th term, what do? I don't need to go through the list to do 1, 2, 3, 4, 5, 6, all the way to 99. All I have to do is just apply this formula, right? Apply this formula. When I apply this formula, they ask for the 99th term. So I just replace n by 99, the index, and 99. And then that term is 3 times 2 to the power of 98. And of course, this is a huge number. This is a huge number. And you can write it down like this. You can write it down like this, okay? And the next one, we have the general term, right? Say if I want to know 23rd term, what will be the 23rd term, right? The 23rd term, if I will replace the n by 23rd, and this will be 23rd, right? So here we can do some simplifying. Okay, so right now we have negative 1 to the power 23 minus 1. 23 minus 1, that's going to be 22. 22 is an even number. So when we have negative 5 to the power 22, we can actually write it down as 2 times, because a negative number is taking the power of even number. So it's going to be positive number. So it's 5 to the power 22. So we can simplify it like that. Okay. And 5 to the power 22 is a very big number. So we can keep that form, but do not multiply 2 with 5. Okay. We have to do the power first and then multiply 5. Okay. So it's here. So it's here. Okay. So that's the caution I wish to give you. Now, in this last example we've done so far, example number 3, if I wish to know the 199th term, 199th term, what would that be? Right, if I wish to know the 199th term, well, all I have to do is that I'm just going to replace the index by 199, right? And this here, 199. And we get 1/3 to the power of 198. And furthermore, right? So this is 198. Furthermore, we also know that we can also write it other ways, because 1 raised to the power 198 is just going to be 1. So 1 over 3 to the power of 198, if you like to write it down that way. Or you can also write it down as 3 to the power of negative 198. All right, so we're not going to show that huge number because this is too big. It's just too big. Okay, now suppose we know any particular term. Suppose we have some information about the first term. We may not know the first term sometimes, right? So we're going to look at an example number 4. So here's the question. We are told, okay, the third term of a geometric sequence is, see the number is 63 over 4. I need my glasses. 63 over 4. 63, excuse me, over 4. Okay, and another piece of information, and the sixth term is 100, it's 1701 over 32. Okay, that becomes a little interesting, right? They give us fractions, and we want to find the fifth term. We want to find, so we have instructions here. We know the third term, and we know the sixth term. Okay, so we want to find the fifth term. All right, let's see how we find the fifth term. Well, if we can find the general term, then we can find any term, right? So what is a general term? We know that the form of general term, right? We derived that. So this piece is very, very useful, very, very useful. Of course, you need to know what things are, right? What A1 is, what R is. Once you know that, from this formula, right, we know the third term. So the third term index is 3, the third term, which is 3, right? And we also know the sixth term, so this is 6. And over here it's 6. And the third term is 63 over 4. 63 over 4. And the sixth term is this big number. It's not terribly big, it's just a fraction. Okay, so we ended up with the following equation because 3 minus 2. Okay, so from here, we will get 3 minus 2, that's 3 minus 1 is a 2. And the next one, if we simplify this equation, we get 6 minus 1 is 5. So we get two equations. We get two equations, equation 1 and equation 2. Okay, so from these two equations, we're going to solve for a sub 1 and r. Once we find a1 and r, then we're all set. We can find any term, you name it. And we can find any term. Now, we're going to call this equation number 1, and the next equation number 2. Okay. So we're going to take the second equation divided by the first equation. Okay, so equation number 2 will divide by equation number 1. Just like that. What that will do is that I'm taking the second equation on the left-hand side divided by the left-hand side on the first equation, and the other side will be equals to the right-hand side on the second equation on top and the right-hand side of the first equation at the bottom. So we're going to simplify. Okay, so that's number 2 divided by number 1. Okay, left divided by left, right divided by right in the same order. Okay, in the same order. So now we get the left-hand side, a sub 1 reduced, r to the power 5 over r to the power 2 is r raised to the power 3 equals to, okay, we're going to reduce this fraction. To reduce this fraction, we're going to multiply the top and bottom by 32. Why 32? Because 32 is a common denominator. As a result, the top is a 1701, and the bottom 4 go into 32, that's going to be 8. So 63 times 8. 63 times 8. Okay. And then we can just simplify it. We just reduce it, right? We get 27 over 8. So 27 over 8 is r to the power 3. And next, what we can do is that we're going to take a cubic root. Okay, we're going to take a cubic root. Okay, root, third root. And the right-hand side and left-hand side, right? The left-hand side is r, and the right-hand side is going to be 3 over 2. So that's our r. Once r is found, right, from one of the equations, right, from the first equation, right, we already have the r. So what we do is that we replace the r by the value we just found, which is 3/2. 3/2, right? We got 3/2 for r, and we're going to solve for a1. Okay, so we're going to simplify that. We're going to get 3 to the power 2, that's going to be 9. So this is going to give us 9 over 4, right? And then we can isolate a1. and we just multiply both sides by the same number. And that same number is going to be the reciprocal of 9/4, which is going to be 4/9. So we multiply 4/9 on both sides. And after that, we reduce it because A1 now is by itself on the left-hand side, and the right-hand side, you see 4 and 4 reduce is 63 divided by 7. Divided by 9 is equals to 7. Okay, so now we got the general term. So the general term by our formula is A sub n, the index, equals to A sub 1 times r raised to the power of an index minus 1. And A sub 1 is 7, right? And the r is 3/2. So 2/3. That's it. That's it. And we wanted to find the fifth term, right? We're asked to find the fifth term. The fifth term is, knowing the general form, the fifth term is just a simple substitution. Index by 5. Substitute it and reduce it. Right, we certainly can and should reduce it, right? That's equals to, that's going to be 4, right? And reduce it. 567/16. Okay, so this is how we can find any term. You can find any term from information about 2 terms in the geometric sequence, and we can identify the first term and the common ratio. Once the first term and common ratio are determined, we can find any term. Okay, so let's do another example. Okay, so this example is, that should be example number 6 or 5. Let me double check. 5, sorry. Okay, now it's asked us to find A sub n. We want to find the general term, right? And A sub 100th. Okay, if the second term, not the third term, sorry. The third term is 12. And the fifth term A sub 5 is equals to 48. Here we go. Okay. All right, so we need to find the general term, and then we need to find the 100th term, and we have information about the third term and the fifth term. So we need to find the first term. We have information about the third term and fifth term. So we need to find the first term, and we need to find the common ratio, right? And so of course, we know this is geometric sequence. Okay, geometric sequence, right? So that's clear, that's clear. Now general term, okay? So solution, since the general term has the form of A sub 1, the first term, multiply r raised to the power n minus 1, and we know the third term, right? From the third term equals to 12, we're going to substitute it, right? n by 3. So that's going to give us, whoops, That's going to give us a sub 1 multiply r squared. And that is going to be 12. So we get one equation here. Okay, we get the first equation. And the second one, all right, the fifth term is 48. So we're going to do the same substitution, but for index equals to 5, right? So this is 5. And that is a sub 1 to the power, multiply r raised to the power of 4. And this time it equals to 48. So now we get the second equation. And from these two equations, we're going to solve for what? We're going to solve for a sub 1 and the common ratio. The common ratio. So how do we solve these two equations? Right? Same trick. First equation, second equation. Okay, I should make the fonts a little bit larger, okay. A little bit smaller, sorry. Okay, so we still divide the second equation by the first equation. Divide the first equation. So the left-hand side, you know, a1, right? A sub 1 r to the power 4 divided by a sub 1 r squared, right, in the same order. And the right-hand side, it's going to be 48 divided by 12, right? And what we get on the left-hand side, we get r squared. And the left-hand side is r squared, the right-hand side is a 4. Okay, and what we get here is that we're going to take square root on both sides. Okay, we're taking square root on both sides. Taking square root. The square root of 4 is 2. Okay, and then the left-hand side is absolute value of r. Okay. And we got two solutions. We got two solutions. So r equals to positive 2 or negative 2. So we have possibly two different sequences satisfying the given condition. Okay, so for r equals to, so we have two sequences, right? We have two sequences. Let's make a table. Right, we have two cases, right? For r, r equals to negative 2 or r equals to 2, right? The sequence, the general term of the sequence would be a sub 1, a sub 1, right? Similar. So let's make 25, 125%, see if we get, yeah, we got it pretty good. We haven't found a1 yet, okay? We're just looking forward. So now with r equals to plus or minus 2, we're going to go back to one of the equations, right? So from the first equation, we can find a1, right? R squared is 4, right? R squared is 4. So we're going to replace r squared by 4. And then a sub 1, as a result, we don't need this. So as a result, a sub 1 is going to be, we have two different r's, but only have one a1. That's going to be 3. So now we can look at our two sequences. Okay, two sequences. The first one, right? if R is -2 and A1 is 3, multiply R, in this case, R is -2. You know, I still like larger fonts though. 75%. How about that? There, this looks better to me. Okay, so A1 is 3 and R is 2 to the power of n-1. Once again, please do not multiply 2 and 3, okay? We need to work on the exponents part and then multiply the 3. And the same is here. So we got two sequences. These are the two sequences. So next question, we're asking, we have the two general forms, right? So we got the general forms. Okay, so we got the general forms, right? So how about there's another question, right? We want the 100th term. We want the 100th term. So what is the 100th term? Well, the 100th term will be, let's see, what's the, oh, sorry. The 100th term, okay, we want to find the 100th term. The 100th term in the R equals to -2 case, right? N is equals to 100. And N equals to 100 in this case, right? And 100 minus 1, that's 99. The other sequence, right? The other one, if R is +2, and that 100th term is going to be 3 times 2 to the power of 100 minus 1. So this is going to be 99, right? Because 99 is odd number, right? So -2 to the power 99, this is going to be a negative number. So in the end, you're going to have a -3 times 2 to the power of 99. Okay, so that's the two cases. That's the two cases for this question. Okay, so that's a geometric sequence. The next thing we're going to talk about is a partial sum again for geometric sequence. Partial sum for geometric sequence is going to be very useful. You're going to use it in Calc 2. Okay, so partial sum of a geometric sequence. Okay, and the meaning we understand, right? We understood it. It's just the partial sum, right? So if we have a geometric sequence, right? So let me pull out the general term, right? We have a geometric sequence, and that's our geometric sequence. That's our geometric sequence. And here you go. A1 is A1, right? A1 is A1. A2 is, you know, A1 times R to the power of 1. And this is the power of 2, 3, and 4, right? Keep going, we have a pattern. The general term is such. So when we consider partial sum, the first partial sum is the sum of the first one term. And of course, that's A sub 1. Okay. Partial sum sub 2. Partial sum sub 2 is equals to A1 plus A2, right? So A1 plus A2. A2 is A sub 1 times R. r to the power 1, of course, is just r, right? You can remove that exponent 1, but it doesn't really make any difference. It doesn't make any difference. And as partial sum sub 3, right, is the first 3 terms. So you're going to have A1 plus A2 plus A3 right here. I'm going to add this piece, right? And we keep going until we found the partial sum of the first n terms, Okay, so what would that be? And that is going to be S sub n equals to A sub 1, the first 3 term, A1, A2, A3. We keep adding, right? And we add A sub 1 r raised to the power of n minus 1, right? So that's the nth term. So S sub n equal first term, adding second term, add third term, adding the last term, n terms, the nth term. Now we want to derive the partial sum. What does the partial sum equals to in another form? So what do we do next? Is that we're going to multiply the partial sum on both sides. Okay, we're going to multiply the partial sum on both sides. This expression on both sides, we're going to multiply by r. So everything multiplied by r. So this multiplied by r, that becomes r squared, right? That becomes r squared. And this piece multiplied by r, now r to the power 3. And this piece multiplied by r, now it's r to the power of n. Okay, and what do we do here is that we're going to line up. Okay, so we're going to line these up. We're going to line them up. Right? We line them up. So after we line up, because this term in front of it is actually A sub 1. Okay, so then let me move it forward, right? The term before this piece is A sub 1 r to the power of n minus 1. Okay, so we have all of these things lined up. You see the way we line up is A1 R1, A1 R2, and so on and so forth. So what do we see here? If we subtract one by the other, right? If we subtract one by the other, how do we subtract it? We take this piece, subtracting that piece on the left side and on the right side. So we have S sub n minus r times S sub n, right? So the left-hand side subtracting the right-hand side. And this on the right-hand side, we're going to take this piece subtracting the entirety of the latter piece. So when we do the subtraction, what will happen? This piece subtracting that is making 0. This piece subtracting that makes 0. So this piece subtracting that equals to 0. So we only have A sub 1 minus, right? Because the top subtract the bottom. So this is going to be A minus A sub 1 times r squared. Okay. Now what do? Now we can isolate the S sub n. So factor out the S sub n, we get 1 minus r multiply S sub n, right? Factored out this S sub n. So 1 minus r equals to, on the right-hand side, we're going to factor out the A sub 1, right? Factor out A sub 1. So inside the parentheses, we're going to have a 1 minus r raised to the power n. And last but not least, provided that r is not equals to 1, we divide both sides by 1 minus r. So s sub n is equals to the entirety of the right-hand side divided by 1 minus r. Okay, so of course here we just mentioned provided okay, r cannot equals to 1. Okay, so this is the partial sum of a geometric sequence. Partial sum of a geometric sequence, which is the sum of the first n terms, can be found from the first term and the common ratio. You can see that, right? So let's see one application of it. Let's look at one application of it. Okay, oh, sorry, what did I do? Okay, so let's look at an example. Okay, let's look at an example. We've done some examples before, okay? So I'm taking one of the examples with 1/3, the general term, right? The general term equals to 1/3 and the, A1 is 1, right? So I like that example, right? So I'm gonna apply this example, which is example number 2. Right here, so A1 equals to 1, A sub n and R equals to 1/3, right? The general term is such, and what will be the partial sum? S sub n is going to be equals to, right? All we have to do is just plug in the formula. Just plug in the formula, okay? Plug in the formula, R equals to 1/3. A1 is 1, right? And the R is equals to 1/3. 3/1, okay? Because this is 1, therefore we can remove that. And just simplify a little, we got on the top is 1 minus 1/3 to the power of n. The bottom is 2/3. Right? The bottom is 2/3. And simplify that, right? And this number will turn into 3/2. Multiply the numerator. Okay, so this will be the partial sum for that sequence. Done. Okay, you guys will use a lot of it, at least quite a bit of it in Calc 2 about the partial sum of geometric sequence. And by now, I think we can close on this section on geometric sequence. Thank you for watching.